Hello guys, this video is about significant figures. This is a topic of science, biology, physics, chemistry, whenever you have a measurement. Okay, let's start from a very simple experiment. Suppose that this is a virus with spherical shape and it has a diameter of d. You may use a very sensitive apparatus to make the measurement over the diameter. But if you do not have such a sensitive one, you may use a very primitive apparatus like a measuring tape and take the virus here. The output of this measurement might be 0, but is it allowed to write the output of this measurement to be d is equal to 0.000000000 meters, infinite number of zeros after the decimal point? The answer is no. First, I recommend do not use such an apparatus to make that measurement, but if you use that, this is not a proper way to do the report of that measurement. The answer to this question will be the last part of this video. I use a weighting scale to measure the mass of a butterfly. Suppose that a small butterfly stands or sits over the sensor, and then on the screen you may see nothing. So the output is m is equal to 0.0. That's it. In mathematics, after the last right zero, you are allowed to add more zeros, something like this. But in physics, you know that we are not allowed to do that because we have not measured the last two green zeros. What should I do? I may use another scale with more sensitivity. As you see on the screen of this scale, I have three figures after the decimal point, and so it's much more sensitive. If the same butterfly sits or stands over that, you may see something like this, and the report is m is equal to 0.002 kilogram. 2 as the last figure, non-zero figure, is named the first significant figure. So please do not add some more zeros based on something you have not measured. Do the measurement and then make sure that they are 0, because based on the second measurement you see that the last figure is not 0, it's 2. So the first significant figure is this. But what is really the significant figure? How should I identify significant figures in a measurement? Rules for significant figures. The first rule is this: all non-zero digits or figures are significant, non-zero ones. For example, suppose that 43 is the output of a measurement. We have two non-zero figures and both are significant. I have two significant figures here. 4.3 will have two significant figures again. Forget about the decimal point, it's not important at all. So 4.38 will have three significant figures. That's it. Suppose that I have this value as the output of a measurement. What should I do here? As you see, I distinguish three different types of zeros here. On the left side, the middle, and on the right side. So what should I do with these zeros? Let's have a definition. These types of zeros on the left side are named leading zeros. At the middle, I have zeros in between or sandwiched zeros. And on the right side, I have trailing zeros. Three different types of zeros. You should know that leading zeros are never significant. So forget about leading zeros. Zeros in between or sandwiched zeros are always significant, and trailing zeros depend. Sometimes they are significant, sometimes they are not significant. When and how? Okay, pay attention to this one. This is an example. 4300, okay? In this value, I have two non-zero figures and two trailing zeros, but I don't have any decimal point. So forget about the last two zeros, and I should have just two significant figures. So the trailing zeros, which are not supported by a decimal point, are not regarded as significant ones. Instead, if you have 4300 with a decimal point at the end, all the figures are regarded as significant. So I have 4 significant figures here. Likewise, if you have 4.300, all figures are regarded as significant. So again, I will have 4 significant figures. So pay attention, the trailing zeros supported by a decimal point before or after are always regarded as significant ones. But if you don't have any decimal point, forget about the trailing zeros. They are not regarded as significant figures. Examples of significant figures. Suppose that the given quantity is 243. It has 3 significant figures because all the 3 figures are non-zero ones. If the given value is 201, it has a 0 in between. The sandwich 0, you know that it is always counted as significant. And so, again, I will have 3 significant figures. If the given value is 200, the last right zeros, the trailing zeros, are not regarded as significant ones. I will forget about the 2 zeros because they are not supported with the decimal point. So I just have 1 significant figure. Instead, if you have 200 with a supporting last decimal point, the 2 trailing zeros are counted as significant ones. So I will have 3 significant figures. If the given quantity is 200.00, all the trailing zeros are counted as significant figures because they are all supported by that decimal point. So I have 5 significant figures. If the given value is 0.0023, just 2 and 3 are the significant figures and the leading zeros are disregarded. So I just have 2 significant figures here. If the given value is 0.00200, the leading zeros are disregarded, but the trailing zeros are supported by that decimal point. I will count them, so I will have 3 significant figures. And at last, if you have 7.0000, all the zeros, the trailing zeros, are counted as significant ones, so I will have 5 significant figures in this case. Powers of 10 are never significant. What does it mean? Pay attention here. Suppose that the given value is 2 times 10 to 3. 2 times 10 to 3 could be rewritten as 2000, and it has 3 trailing zeros. We will disregard them and just I have 1 significant figure here. 10 to 3 is just the 3 trailing zeros and nothing else. Sometimes 10 to negative 3 like this in this value will have the role of the 3 leading zeros and it's disregarded again. So as you see, 10 to 3, 10 to negative 3 are trailing zeros or maybe the leading zeros and so on. They are not regarded as significant figures. Pay attention to this one. But the last thing is this. You may have 2000 with a supporting decimal point at the end. Here, you should write it mathematically like this, 2.000 10 to 3. Pay attention again, 10 to 3 is disregarded, but anyway, on the right side or on the left side, you have 4 significant figures because the last trailing zeros are supported with that decimal point. Okay, let's go back to the initial question. What should we do with this measuring tape and the diameter of the virus? Okay, pay attention. In this measuring tape, the minimum graduation is 1 millimeter, is 0.001 meter. You can't measure smaller than this value. The minimum size of your measurement with this measuring tape is this, 1,000th of a meter. So your report will be something like this. You will measure the 3 zeros after the decimal point and you guess the last one. In the next videos, I will teach you how you guess the last one. So pay attention that anyway, in this measurement, you will have no significant figures because all are 0 digits and so they are not significant. Hope you have enjoyed this video. If you like it, push the like button and subscribe.